Hello, and welcome back to our series on finding an unfair D6. Now, what do I mean when I say a fair D6? I mean that when you roll, the likelihood that any side is going to come up is identical. So let's look at what that actually means. We'll just move this stuff up and out of the way. I won't be rolling dice in this particular video. I already rolled dice for today. That video will be up. So here is, I keep calling it a D6, okay, because it has 6 sides. All right. Now, because there are 6 sides, the likelihood that one of them comes up is 1 in 6. All right, so if the die is fair, that's the likelihood that one of the sides will come up, any one side. So let's take 5, for example. All right, 5 on the white die. The likelihood that 5 comes up, if the die is fair, is 1 in 5, or 1 in 6, sorry. Likelihood that 5 comes up is 1 in 6. Now, how many times did we have 5 come up? Now, this is 4 boxes, 2 boxes tall, so that's 8 total. So we had it come up 8 times. All right, now it wasn't all at once, all right, so this is not necessarily a fair comparison. Let's assume we had all 8 of those 5s come up at once. What would that look like? Well, the first roll was 1 in 6. The second roll is 1 in 6 because the first roll does not impact the second roll, okay? And we have 1 in 6 for the third roll and 1 in 6 for the fourth roll, 1 in 6 for the fifth roll, 1 in 6 for the sixth roll, yep. 1 in 6 for the seventh roll, finally 1 in 6 for the eighth roll. Okay, and the reason we multiply them together is because in statistics, if you have 2 events that do not affect each other, okay, they're independent events, when you are looking at the probability that both events happen, you multiply the probability that either event happens together. All right, so what is this? This is 1 over 6 to the 8, because it's 1/6 times 1/6 and so on. All right, which equals, let's get out our calculator, okay? 1 divided by 6 to the 8th, just because I like the notation of having that. So look at that, okay? It's this hugely small number. Okay, this right here means that it is 0.00007 zeros and then 595. Okay, so that's not very exciting to look at on the calculator because we can't write it out and see how small it really is. So let's look at just 1 over 6. It's 0.166666666, and the 7 here indicates that we just round it. So the likelihood that the 5 came up in the first place, I forgot to write this number down, 5.9537, and I'm just going to stop rounding there, times 10 to the negative 7th, which is equal to 0.1234567595337. Okay, so we have, this is what 1 would look like, all right? And typically in statistics, and this is the way I was taught, there are different conventions, but in statistics we typically look at the 4th decimal place. Okay, so if we looked at this and we said, what is the likelihood that you roll 5 8 times on a 6-sided dice? We would say not statistically significant. Okay, it is insanely unlikely. The reason is because this is the likelihood that that will happen, or that not that will happen. Okay, that something other than this exact 8 5s in a row will happen. Okay, and what is that number? Let's see. 1 minus point 1, 2, 3, 4, 5, 6, 7, 5, 9, 3, 7 is 0.99999, and so on. Okay, now we have that number there. But if we're looking at only the first 4 decimal places, okay, that approaches 1. All right, so the likelihood that something other than rolling 8 5s in a row is going to happen is really close to 1. All right, so that is why rolling the d6 a bunch of times is maybe going to give us a die that's unfair. Now I say maybe because it is entirely possible. There is an edge case. We literally just looked. It is a non-zero probability that you can roll 8 in a row. Okay, now what is the likelihood? I'm going to roll, so how many days have I done this in a row? 5 days in a row. So I've rolled 25 times. I'm going to roll 75 more times. What is the likelihood that I get 75 more times? It would be 1 over 6 to the 75th power. That is non-zero. Okay, if we plug that into our calculator, we're not going to get 0 back. We're going to get a non-zero number. Now it's going to be a very small non-zero number. Okay, it is still, in the strictest Euclidean sense, possible. Okay, so that is why I say might find a die that is unfair. Now, in reality, if I find a die that keeps rolling the same number, okay, I would expect it to keep rolling that same number. Okay, now you have to have a sufficiently large sample size, which is why I'm rolling 100 times total, not just rolling 10 times and calling it good. You have to have a sufficiently large sample size for these kinds of numbers to change. All right, so if we have this probability is what we expect, and then this happens, we would look at the die and say, okay, probably there is something going on where this die is not actually balanced. If that happened, I might actually do the scientific, putting it in the saline solution and doing the bobbing test. But, I'm not going to worry about that until I actually get there. As I told my nephew, because I forgot that he is a child, I'll burn that bridge when I come to it. So, yeah, I'm going to keep rolling the dice to see if I get any huge spikes. These are not huge spikes at this point. This is 8 out of 25 rolls. When I've got, 30 out of 50 rolls, then maybe we can talk about it being an actual huge spike. But as it is right now, it's a relatively small spike because all of the numbers are relatively close. I just need 4 more of these 2 numbers and I'm there. I need 3 more ones and I'm there. So it's not an unheard of possibility for me to get 3 ones, right? What is the probability of that? 1 over 6 cubed. Okay, so it is entirely possible, and I would say, because I want to put faith that the dice are fair, I would say it is likely that I will get more 1s and have a fairly even stack of 1s and 5s when it's all said and done. So there you go. I will see you guys, well, I guess you will see my dice in the next video.